All right, so in this problem, it says you're installing a new spark plug in your car, and the manual specifies that it be tightened to a torque that has a magnitude of 45 newton meters. Using the data in the drawing, determine the magnitude F of the force that you must exert on the wrench. Well, there's a couple of ways of doing this because you can either use that torque equals F perpendicular times L, where I'll be adjusting the F to be perpendicular to the L given in the problem, or I could be adjusting the L and not changing the F. So I can do either one. Now, looking at the picture, actually, the F is in this direction, so the L would be, so if the F is horizontal, the perpendicular to that would be vertical. So that is the length of the wrench. The force is being applied at this distance away. So if I went straight down, that would actually represent L perpendicular. So I could solve it that way. Another way is I can leave the L like that, but then I would need my F perpendicular in that direction. So there's two ways of doing this. I suppose I'll do this way first, and then I'll show you the other way. If I do it the first way, what I would be doing is I'm going to take this, and if I follow this down like that, and then follow this over that way, it gives me a better idea of what the angle is that I want to use as my reference angle. Because if I do that, I can see that if that's 50 degrees right there, then that's 50 degrees. And these two angles are what to each other? Not supplementary, complementary. They add up to 90 degrees. So if that's 50, then what is this angle right there? That's 40. So if that's 40 degrees, now this is now my triangle. I'll use a different color here. So my triangle is I go in that direction, and then I go in that direction. So it's this component right here that's the perpendicular component. So in the formula F perpendicular, it's that. Now the angle, I know the angle, and I want to write this in terms of that. So that is my F perpendicular. So what will I write when in solving for torque? What will I replace F perpendicular with? What side of the triangle, that's a right triangle that I formed, what side of the triangle is F perpendicular? Is that opposite the angle 40 degrees, or is it adjacent to the angle 40 degrees? Adjacent. So what trig function do I use? Cosine. So I get F cosine theta times the L, the full L. And then we can, so what we know is we know the torque and we know the L. What we don't know is the F. So the question is, determine the magnitude F of the force that you must exert on the wrench in that direction. So if we rearrange this equation to solve for F, we're going to get torque divided by, I'll put the L in front, L cosine theta. And then just put in the numbers. So we're going to have 45 Newton meters divided by 0.28 meters times the cosine of 40 degrees. And if you solve that, what do you get? So you get 210 newtons. You do that? Okay, so 210 newtons. Yes. Yeah. Okay, so the other way of doing it is using the other equation here, this one. This one I actually think is easier to use for this problem. Because to use the second equation, I don't have to make these lines to figure out what that is. Like these are vertical angles. So I did that in order to figure the 40. But the 50 degrees is right there. So if I drop a line straight down vertically from where the wrench is being applied. So if I drop a line straight down, what I just drew is going to represent L perpendicular. So my formula, if I had done it this way, is going to be the full F, because the F is horizontal. So it would be F times, now I'm going to replace, I'm going to write L perpendicular in terms of L. So that's the hypotenuse of this triangle. That angle right there is 50 degrees. So what side of the triangle is that? Is that the opposite side or the adjacent side? So what trig function do I use? Sine. So it's going to be F times L sine of 50 degrees. And the sine of 50 degrees is the same thing as the cosine of 40 degrees. So we're going to get the same answer here, solving for F. So I would be getting F is going to equal torque over, actually over here, over here I actually put in the, like I left it as theta and then put the angle, but we got two thetas here, right? This theta is, you know, that theta is different than that theta. So I put it in over here instead of just leaving it as theta because it's a new theta. So it's going to be torque over L sine of 50 degrees. And you can see you'll get the same answer here as you got over here, because the only difference between the two is one is the cosine of 40 and the other is the sine of 50, and those are the same numbers. Right? Any questions?